A fast fuzzy decoder consists of components that carry out a simple difference function, and these components are connected according to simple rules of logic. For vision, the components are neurons. But FFD components could be anything that performs the difference function. The components produce output signals with intensities that can have any value between 0 and some maximum, referred to here as 0 and 1, or 0% and 100%. The inputs are also any value between 0 and 100%. An FFD can have any number of inputs. This model of color vision has 3 inputs from photoreceptors, or light sensors, in the retina. Each component has 2 inputs. The first, indicated by an arrow, causes the component to produce a signal, and the second inhibits the signal. The output is the difference of the inputs if the first is greater than the second. Otherwise, the output is 0. For these 2 cells, the differences are illustrated geometrically by these vertical bars. Go up 70, come down 30, and you're at 40. For color vision, violet and purple are exceptions to this difference rule, and this FFD is modified to take that into account. For an explanation, see the violet and purple section here. Now, real neurons are nonlinear devices, which simply means their outputs are measures or approximations of these differences rather than the exact differences, but that doesn't change the effectiveness of the fuzzy logic. The connections are determined by the logic identities of Table 2 in Article Number 2 in the Related Articles page on the Fast Fuzzy Decoders website. The identities are recursive and reductive, which simply means you start with an FFD output and a logic identity tells you what 2 inputs produce that output. The same identity tells you what inputs produce those outputs, and so on all the way back to the FFD inputs. That's all there is to it.